Okay, 9.6. So we're running through this. This is fundamentally to deal with the sum. Okay, similar as before. A is the first number, or is the ratio, n is the number in the sequence. Now, I've given you two different ways. The book is just giving you this way. This is when or is greater than 1. This is when or is less than 1. It doesn't actually make a difference. Both will work out. I just think it's better if you do it like this. Just one important thing. If I gave you a sequence that's 1, 3, 9, 27, how do you know, if it wasn't numbers, it was letters or something, how do you show it is geometric? Sorry, it's Tn over Tn minus 1 equals to the ratio. That's all you got to show. Yeah, and that's got to be a constant. Okay? And then if there was some number thrown in, I'm sure they gave you 1, 3, x, and something x there. Okay, if you t3 over t2 equals to t2 over t1, you'd work it out from there. Pretty straightforward. Now, on to the questions that we need to know. If I give you the following, 1, 3 plus 9 plus 27, that's the sum. Yeah, A is 1, or is 3, because it's multiplying by 3 each time. Or is greater than 1, so I'm doing S of this. What are they asking for? S of 5. I'm going A, which is 1. I'm using this one up here. Or to the power of 5 minus 1 over 3 minus 1. That's going to give me, put into your calculator, 1 over, or 341 over 256. Okay, really straightforward. I had to explain where this comes from on the top of page 349. I'm not sure how important that is to know, but so be it. Right, example 2 is a bit better. To give us t of 3 equals to 32. So I say a or n minus 1, so that's going to be 2 equals to 32. And they give us t of 6 equals to 4. That's a or to the power of 4 equals 4. I'm straight away thinking, well, a equals 32 over or squared. Yeah? So now sub it in here. 32 over or squared, or to the power of 4 equals to 4. Therefore, that's 32 or squared equals to 4. Divide across. 4 divided by 32 is 1/8. Or square equals to 1/8, or equals to square root of 1/8. Okay? Plain simple, easy enough. Then sub it back in. We get our a. Sub it back in up here. A is 32 over or squared. Square that out, that's 1/8. So A comes out at 128. Now, that's pretty easy. Yeah, that's pretty easy. Now, example 3 that we're going to go through here is find the sum to infinity of the geometric sequence of 16 plus 12 plus 9 on forever. Kind of links back into what we did before, but it's with our limits. So A is 16, or is 12 over 16, which is 3 over 4. And then I'm going along here and I'm putting in my S of n as normal. Sorry, wrong one. S of n is or is less than, so it's a 1 minus or to the power of n all over 1 minus or. Now, a is 16. If you think 1 minus 12 over 16 to the power of infinity, anything less than 1 to the power of infinity goes to 0. 1 minus 12 over 16. So that's going to go 16 by 1 minus 0. And then that's going to go 4 over 16. And our answer is going to be 255. yeah, if my, sorry, not 255, it's going to be 64. And that's that sorted. Nothing groundbreaking to that, nothing hard. Here's the important one that you need to know. Decimals, and how to rewrite this out. If I give you 0.23, like that, that is 2 dots above it, in case it's a bit blurry here. That's 0.23, 23, 23, 23. This comes up in the lever quite a lot. So, take this one first. That's the same as 23 over 100. Plus 23 over, add 2 zeros. 1,000. Plus 23 over, add another 2 zeros. So we're at 1,000, 100,000, so on and so forth. So A equals 23 over 100, or equals to, divide this into this, it's 100, to zeros I've added. And now, I'm finding S to infinity. So that's A, which is going to be 23 over 100 by or, 1 minus or, which goes to 0. I know that you say 1 minus or, but I'd like you to understand what you're doing. Or to just say A over 1 minus or. So that's 23 over 100 over 99 over 100. Therefore, E equals to 23 over 99. Now, how to rewrite these out? If I gave you the following, 0.465. The dot is at the 4 and the 6. That is 0.465, 465, 465. How would I write that out? 465 over 1,000, given that there's 3. So we go 3 zeros, plus add another 3 zeros. And we're kind of done. A is 465 over 1,000, or is going to be over 1,000. Okay, and then you can work it out from that point in there. Questions that I want you to do are going to be page 352, and I want you to do 45 minutes of work there. Yep. Okay. Hope so. It's good.